Let's talk about segment bisectors. A segment bisector divides a segment into two congruent segments. It might be a line, array, or a segment. Well, let's break down this definition. What does it actually mean? Well, we all know what a segment is. It's an infinite collection of points confined between two endpoints. But what's a bisector? When you see the prefix bi, like bicycle, you should think two. And the sector part basically means cut. So it's a segment that's been cut in two. Now you might be hung up on the word congruent. That might be a new word for you. Congruent basically means equal. Equal has to do with numbers, congruence has to do with shapes, but the two concepts go hand in hand. If two things are equal, then they're congruent. And if two things are congruent, then they're also equal. So anytime we're talking about segment bisectors, you should be thinking about a diagram that looks something like this. Basically, two lines intersecting each other. But they intersect each other in a special way. In this diagram, WZ is the segment bisector of segment XY. The reason is because XY has been cut into two congruent segments. XV is congruent to VY. So this might be a new symbol for you as well. This is the symbol for congruence. It's basically just an equal sign with a squiggle on top. And that's because congruence and equality go hand in hand. If two things are congruent, then they're equal. If two things are equal, then they're congruent. And these two little markings might be new for you as well. These little marks on each of these segments imply that these two segments are congruent to each other. They're the same length. So let's take a look at a couple of examples. I want you to analyze this diagram and determine which thing is bisecting which. The segment bisector is the figure that cuts a segment in half. The segment that was cut in half is not the segment bisector. So let's look at what's going on in this diagram. I see these two congruence marks, which means that DB is the same thing as BE. They're congruent to each other, they're the same length. So DE is the segment that got cut in half. Well, what cut it in half? Line AC did. AC intersects DE at point B. B is actually called the midpoint, which makes AC the segment bisector. So I can say that line AC bisects segment DE. Now I want you to pause the video and try this one on your own. Fill in those blanks. What bisects what? Give it a try. The correct answer would be that ray KM bisected segment NL. NL has been cut into two congruent segments, NJ and JL are marked as congruent to each other, and the thing that cut it in half is ray KM, because KM goes through the midpoint of that segment, point J, so KM is the segment bisector of segment NL. On our next example, we're going to need to do some labeling on our diagram. The directions tell us that PR bisects ST, and that ST is 12 inches. So how long are segments SQ and QT? Well, since PR is the segment bisector of ST, that means that ST must have been cut in half. So I'm going to draw those little congruence marks on my diagram to indicate that SQ and QT are congruent. They're the same length. And I'm also going to label that ST is 12 inches. I'm going to put that on my diagram like so. From point S to point T is 12 inches. So the question is, how long are SQ and QT? Well, they have to be the same length, right? And they have to add up to a total of 12. So basically all you need to do is divide 12 by 2, divide it in half. So both SQ and QT must be 6 inches long. Let's try another example. This time I'm told that ray GI bisects segment FH. And I'm told that FG is 26 meters long. Well, if GI bisects FH, then FH must have been cut into two congruent segments. So FG and GH can be marked with congruence marks to indicate that they're the same length. And I can label that FG is 26 meters. Well, if FG is 26 meters, and FG and GH are really the same thing, then GH would also have to be 26 meters. So how do I find the length of the entire segment? Well, you can actually just use the segment addition postulate for that. I can tell that FG plus GH equals FH, and I know that each FG and GH are 26 meters each, so that must mean that FH is 52 meters long. Initially, looking at our next example might feel a bit overwhelming because there's numbers and variables all over the place. But the first question really just asks, what thing bisects what thing? So if I look at my diagram and kind of ignore all these numbers and variables and stuff, and instead just focus on these two congruence marks, these marks tell me that DB, this segment, was bisected into DE and EB. So what did the bisecting? What cut DB in half? That would be AC. So segment AC bisects segment DB, which again I could tell because of these two congruence marks. And since those congruence marks are put on the diagram, I can assume that DE is equal to EB. Then I can substitute the algebraic expressions I see on my diagram for each of those segment lengths. DE is 7x minus 12, and EB is 3x plus 16. Now let's solve this equation to calculate the value of x. I'm going to subtract 3x from both sides, and then add 12. I'll divide by 4, and I find out that x equals 7. But remember that that's not actually what I was asked for, or at least it's not the only thing I was asked for. I was asked to find x, but I was also asked to calculate the lengths of each segment. So now I need to plug x in to figure out each length. So DE, instead of 7x minus 12, I'll say that DE is 7 times 7 minus 12. And that gives me a length of 37 units. Let's do the same thing for BE. 3 times 7 plus 16 would give me an answer of 37 units as well. And it makes sense that I got the same answer for these two segments, right? That was kind of the whole point of this problem, that DB was bisected, which means these two segments had to be equal to each other. So if I had gotten something other than the same number for both of these, I would know that I got the wrong answer for x. Do you think that AE and CE are going to be equal to each other as well? Well, let's find out. I'll plug in 7 to calculate the length of AE, and I get an answer of 43 units. And then I'll do the same thing for the length of CE, that's just 4 times 7, which is 28 units. So no, they didn't end up being equal, but I had no reason to believe that they would be. The only segments that I knew would be equal in this diagram were DE and BE because DB was bisected by segment AC. And that's all you need to know about segment bisectors and the segment addition postulate. In our next video lesson playlist, we'll talk about a very similar concept except with angles. It's called the angle addition postulate. See you then!